The first question, a mass capital M is broken into two parts. Then you keep it as xn m minus x. How are the mass related to each other? Such that the force of gravitation between them becomes maximum. For maxima or for minima, the dy by dx, that is differentiation value, can be equated to 0, and that's the point at which the maxima or minima can occur. So then I'm just taking, okay, so let me delete this. So I'm just taking the force value G into capital M into M1 M2 by R square, where M1 is x and the M2 is M minus x, and differentiate this with respect to x. But G by R square is a constant, take it out. Take x into M minus x and differentiate as U and V. UV. U first, the differentiation of M minus x is minus 1. Why? M is a constant differentiation is 0. X differentiation is 1, and so minus 1. M minus plus, just write the second term as it is. Differentiate the first term, which is 1, is equal to 0. That's what you're supposed to do. So minus x. So then is plus M minus x is equal to 0. M minus 2x is equal to 0. M is equal to 2x and x is equal to M by 2. So that's how you get the relationship between how you should bifurcate this capital M as equal parts in order that the force has got to be maximum. So let's go to next question. The radius of the earth shrinks by 2%. Mass is remaining constant. The moment you see that the radius is shrinking by 2%, you find the new radius r minus 2 by 100 of r. So 0.98 r is the final radius, new radius now. How would the acceleration due to gravity be affected? Small g is equal to g capital M by r square is the initial one, and g dash is equal to g capital M by 0.98 r the whole square. So you know the old gravity and you know the new gravity now. So to find the percentage increase in gravity, the formula is g minus g dash by g into 100, or g dash minus g by whatever you can write plus, and so then find the percentage increase in gravity due to the percentage decrease in radius. We can't call it as increase in radius, it shrinks, correct? So just calculate this value. A man jumps 1.5 meter high on the earth. Okay, man is able to jump only maximum 1.5 meter because after that his velocity becomes 0. So just put it in v square minus 2a square, v square minus u square is equal to 2as, and s you call it h maximum. That itself is only 1.5, and so you get a formula for h maximum, which is u square by 2g, and conclude that h is inversely proportional to gravity. The gravity is more, you can jump only less height. Gravity is less, you can jump more height. Now go to the next point. Calculate the approximate height that he might be able to jump on a planet whose density is 1/4 of the earth and whose radius is 1/3 of the earth. So there is a planet which is having a density rho dash, which is rho by 4, and who has got radius r dash, which is r by 3. So the moment they give density, you know g is equal to, small g is equal to g into capital M by r square, right? M as 4/3 pi r cube into rho. Density is mass by volume, mass is density into volume. And so when you do this, now you can write g dash is directly proportional to rho into g. Rho into r, sorry. Because 4/3 pi g, and all is constant. So write it as r by 3 and rho by 4. Rho by 12. G dash is therefore, can you see, compare, it's becoming, what would have been the original gravity? The original gravity would have been gm by r square, where m is 4/3 pi r cube into rho, where r cube and r get cancelled. So the original gravity is directly proportional to, the gravity is directly proportional to rp. The final gravity is proportional to r rho by 12. So since the original gravity is proportional to r into rho, the final is proportional to r into rho by 12. You can divide this equation by the this equation. Equation A can be divided by B. You can get G dash to be G by 12. You can get G dash by G to be RP by 12, R rho by 12 by R rho. So G dash is G by 12. So that's how I got this. I hope you are clear. So just get the proportionality first for G. Once you know that G is directly proportional to R into rho, you write G dash therefore is proportional to R by 3 into rho by 4. So you can find the association between the G dash and G. But they're asking height to which he can jump, for which height is inversely proportional to G. So H dash, the new height by H is equal to G by G dash. You know G by G dash is G 1 by 12. Already you have found it here, 1 by 12, G by G dash. And you know the gravity H that he can normally jump in the ground is 1.5 meters. Just substitute that value and get the answer. At what height from the surface of the earth the value of G is reduced to 36%? The moment the value of G is reduced to 36%, G dash is equal to G minus G into 36 by 100. So just calculate this. The new gravity you got. What value of height from the surface? So the gravity at a particular height, formula G into R square by R plus H the whole square. And that's equated to this. That's the formula. Equate that to the G dash that you calculated so you can find the height. So let's go to next question. At what height from the earth's surface the value of gravity is half? So first write G dash is G by 2 and put at height formula. GH is equal to G into R square by R plus H whole square and equate 1 with a 2. What is given in the question is 1. What formula is 2. I equate both of that. You get you can find H. Okay, let's go to next question. Find the percentage decrease in the weight of the body taken to height of 32 km above the surface of the earth. So 32 km is a very small height. Okay. So therefore you can use the approximate formula of gravity at a particular height is G into 1 minus 2H by R. So you get the gravity at a particular height like this. And then do G minus G dash by G into 100 to find the percentage decrease in gravity. Because you know the gravity as you go up will be less only. So G minus G dash by G into 100. And this is G dash and G, you know, just take it out and get the answer. What is the relation between height H and depth D for a same change in gravity? This we already learned it. You equate the GH is equal to GD and D is equal to 2H. You know this. How much below the surface of the earth does the acceleration due to gravity become 1% on its surface? So just put 1% on the surface. Do this arrow mark first. New gravity is G minus G into 1 by 100. You get the new gravity. And this is the gravity which is going to be below the surface of the earth. So put the formula for below the surface of the earth and equate, write it as 2 using formula and equate 2 is equal to 1. G and G get cancelled. 1 minus D by R is equal to 99 by 100. D by R therefore is 1 by 100. So cross multiply and get R. And R itself is 6.4 into radius of the earth, right? Into 10 to the power 6. 6,400 kilometers by 100, and so hence write what is the value. So let's go to next sum. The two bodies of masses 10 kg and 1000 kg are separated by distance of 1 meter. So then from the point on the line joining 2 points, you don't know the gravitational field is going to be 0. Let's assume that this is where the gravitational field is getting to be 0. So let's consider the left hand side as x and the right hand side as 1 minus x. What is gravitational field intensity formula? Is F by m, Gm by r square. Let's do the gravitational field for the left hand side, G capital M by x square. For right hand side, G capital M dash by 1 minus x the whole square. M and M dash or 10 kg and 1000 kg, plug in the value, G get cancelled, cross multiply, get the answer. Find the escape velocity of the planet Earth. You know the derivation. And just plug in the value. I know 11 kilometers, 11.2 kilometer per second. An Earth satellite makes a circle around the Earth in 90 minutes. Seconds, it's 90 into 60, 40,400 seconds. Calculate the height of the satellite above the Earth's surface. See, normally, from the center of the Earth, it is r plus h the whole cube is equal to t square g r square by 4 pi square. R plus h the whole cube. But they are not asking r plus h the whole cube, they are asking h in particular, height above the surface. But we can find r plus h and eventually take the r to the other side and find h. I am considering this to be small r cube and taking the 1 by 3 to the other side as 1 by 3. Substituting, I get r plus h and take the r to the other side and do the calculations. Use a calculator for now and then do the calculations in the exam. As long as you write till here, at least conceptually be very strong. An object is projected vertically upward from the Earth's surface to reach a height 9r. Okay, r is the radius of the Earth's surface. An object is projected vertically upwards from the surface to reach a height, h is 9r, which means h is 9r. From the surface of the Earth is 9r. So totally from the center it will become 10r. Okay, fine, keep it like that. What is the velocity required to project it to 9r? We should understand when a body is projected from the surface of the Earth. Let's consider this to be the Earth. From the surface of the Earth, it's projected to a height which is 9r from the surface of the Earth. The energy at the bottom should be equal to energy at the top. Energy at the bottom will have kinetic energy plus potential energy because you are also going to project it. Energy at the top is only potential, there is no kinetic. Energy initial is equal to energy final. The difference is the potential energy G minus G capital M small m by R plus H, whereas in this G capital M small m by R. Thus you can find the energy with which you are supposed to project or velocity with which you are supposed to project if you do this calculation. Taking it to the other side and finding the LCM and cancelling, and then you get a simple formula which is this, and in the place of h you can substitute 9r and hence do the velocity and just plug in the values. Calculate the period of revolution of Neptune around the Sun given that the diameter of the orbit is 30 times that of the diameter of the Earth. Orbit's diameter. You know Kepler's law. T square is proportional to r cube. The T of the Neptune the whole square is proportional to R of the Neptune the whole cube. T of the Earth the square is proportional to R of the Earth the whole cube. Dividing 1 by 2, the constants will anyway get cancelled, no? So you get like this and substitute radius of the Neptune to be 30 times the radius of the radius. And so things get cancelled. And you know the time period of the Earth is 1 year. Cross multiply, get the time period of Neptune. Very, very important, sir. Next is the the distance of two planets from the Sun. So to 10 to the power 13, R1 and R2 have been given. Find the ratio of the time period. T1 square by T2 square is equal to R1 cube by R2 cube. R1 R2 plug in. Just take it the power in. Just move it to get 10 to the power 3, which is T1 square by T2 square. But you want T1 by T2, take the square to the other side, becomes 1 by 2. You can write 10 to the power 3 the whole to the power 1 by 2 as 10 to the power 1 by 2 the whole to the power 3, which is root 10 the whole to the power 3, which is 10 root 3. You get this answer. Next, what are they asking? The ratios of the speed v1 by v2, 2 pi r1 by t1 is equal to 2 pi r2 by t2, r1 by t1 into t2 by r2. So you get something like this. You know T2 by T1, which is reciprocal of this, which is 1 by 10 root 10. You know R1 by R2. Just do the calculation and find the velocities ratio. MCQs. Reason for weightlessness in the satellite. MCQs are quite complicated MCQs that they have given. Satellite, you feel weightless. This is the reason, actually, the actual reason is this. I've written here. A satellite is continuously falling on the Earth. It's getting attracted towards the gravity, but yet it doesn't fall into the Earth. Why? It's like a ball which is getting thrown with such high velocity. Can you imagine that it's going to flow like this without falling? The earth is also in this shape. So then it'll start ellipting around the earth. So that's the reason. That's the orbital velocity with which you are projecting. So the satellite, the horizontal component of the velocity keeps it continuously moving even though the gravity is continuously pulling it towards the center. A satellite is in continuous state of free fall towards the earth, but yet due to high sideways velocity, it ensures it never hits the ground. It's a very important question. So there's zero reaction force by satellite surface. Don't feel the gravity, there's no normal reaction. So see, if the change in the value of gravity at a height h above the surface of the earth is the same as depth, d is equal to 2h. At what depth below the surface of the earth, acceleration due to gravity will be half the value. So g dash is g by 2. At what depth? So write the depth formula. G dash is g by 2, half the value of at 1600. No, you can't write. At what? Half the value of 1600 kilometers from the surface of the earth. Above the surface of the earth, 1000 kilometers, gravity at a particular height formula, you write. 1600 above the surface of the earth, the radius of the earth is 6400 plus 1600, so 8000. R plus S whole square, plug in that, I get the gravity at a particular height like this. At what depth? The gravity at a depth is gh by 2. Because they are given. At the particular depth is half of the gravity at a particular height. So then therefore plug in what is gh you found it. Just plug it in with dividing it by 2. So the 16 becomes an 8 and it comes here. Equate substitute g into 1 minus d by r. That's a formula for gravity at a particular depth is 1/2 the value of gravity at a height of 1600 kilometers. So equate both of this and get the value. The weight of the body at the center of the earth is 0. Obviously, at center there is no gravity, so weight we feel 0, weightlessness. The earth is supposed to be a sphere of radius r, and if g 30 degree, which means g lambda, gravity at a particular latitude is g 30, the latitude angle is 30 degree, g is at the equator, then the value of g minus g 30. Okay, a lot of people had messaged me that you didn't understand this quite well, so I'm doing this alone separately here, so please understand. To find the gravity at a particular latitude, what is the latitude? Take a point on the earth's surface, join it with the center of the earth. The angle that it makes with the equator is what is called latitude. So every point on the earth will have different angles with the equator. That's called 30 degree northeast, whatever latitude they talk about. This is radius r. Supposing I am standing on this surface, the earth is going to pull me towards the center with the force mg. And when the earth is spinning, you don't realize that the earth is moving. You see the magic, I'm sitting here, but the earth is spinning 24 hours. This is smaller. You can construct a triangle also with smaller. This radius is smaller, and therefore there will be a mr omega square, which is a centrifugal force. And so then breaks down into component. Because it's lambda, this is mr omega square cos lambda, and the component mr omega square sin lambda. And to find mg lambda, gravity on the surface due to latitude, is a net force acting on it, which is inward force, which is mg, minus outward force, which is mr omega square cos lambda. Small m throughout get cancelled. You can find, interior alternate angle. If this is lambda, this can also be lambda, and hence a cos lambda from this triangle is small r by capital R. Small r can be written as capital R into cos lambda. So then g lambda is equal to g into capital R omega square cos square lambda. You get another formula, which is a very important formula. and you want g minus g lambda, you take it to the other side, move it this to the other side, r omega square cos square lambda. This is the formula to find the difference in gravity minus gravity on the surface minus gravity on a particular latitude. So going back here, I hope you understood the derivation. I thought that was omitted portion. Okay, but I've done it now. So then therefore you substitute cos 30. Cos 30 is root 3 by 2, square root 3 by 4 r omega square is the answer, right choice. Weight of the body is maximum at the poles only. They'll ask you, is it at the equator, blah blah blah. You know, gravity is inversely proportional to the radius, and radius of the pole is smaller, and so the gravity of the poles is greater, and the weight is also more at the poles. The angular speed of the earth in radians per second, so that the object is at the equator may appear to be weightless. In equator, lambda is 0. So mr omega square cos lambda is not the mr omega square cos 0, which is 1, will be equal to mg. Equate that. You get omega square is g by r, omega is equal to root of g by r, substitute the value. Our radius of the earth is 6,400 kilometers, so then approximate it. Which of the following quantities does not depend on the time period, radius of, which is a constant? The t square by r cube according to Kepler's law is a constant. T square is proportional to r cube, so it is not always a constant, does not depend on anything. In fact, radius of the satellite, orbital radius. The ratio of the distance of two satellites from the center of the earth is 1:4. The time period is merely Kepler's law, substitute, get the answer. A body is projected from the earth's surface to become its satellite. Its time period of revolution will not depend on its own mass, because you know time period's formula. Remember, time period is root of 3 pi by rho g. Of course, it was r plus h whole cube by r cube, where we considered h is negligible. We talked about 1 hour and 24 minutes of timing. So that it is independent of the mass. Even it can depend on the mass of the bigger object, because density is there. This derivation, just to recall, in a gravitational field of a body, if a body is bound to be with the earth, then the total mechanics, if a body is bound to be the earth, there is no escape velocity. It can never escape into the outside world, which means how much ever kinetic energy I give, the potential energy has a bigger value. That the net energy doesn't become zero, or the net energy doesn't become positive, it always remains negative. The total energy should always remain negative. The kinetic energy's magnitude should be always lesser than the potential energy, so that the kinetic energy cannot overcome the potential energy, is not able to escape. The total energy should always be negative. Hope you understood. The binding energy of an object of mass m placed on the surface of the earth are, binding energy is a potential energy, it's a Gmm by capital R, where in the place of capital Gm you can substitute Gr square, so mgr on the surface of the earth. The escape velocity on the earth is 11.2 km per second. What will be the escape velocity on a planet whose mass is 1000 times, the radius is 10 times that of the earth? Write the escape velocity formula. You have to use this formula because mass is 1000 times the mass and radius is, so you have to stick to this formula, write the ratios, substitute for the earth 11.2, substitute for the planet x, and get the value. When escape velocity is given to a particle on the surface of the earth, its total energy is 0. The kinetic energy should be equal to potential energy. That's when it's able to escape. The escape velocity for a body of mass 1 kg from the earth's surface is 11.2 km per second. The escape velocity for a body of 100 kg. Escape velocity does not depend on small m at all. Escape velocity is root of 2g capital M by r. Is independent of small m. Find the potential energy of 4 particles placed on the vertices of a square, side 1 meter. Potential energy formula is minus g capital M small m by r. So you have a potential energy g capital M 1 by 1. This one, 4, and then this one and this one, where the distance becomes root 2, not 1. So 2 times and 4 times calculate the total potential energy. The magnitude of the gravitational potential energy of a body at a distance r from the center of the earth is u. Some potential energy at a distance r from the center of the earth is u. If its weight is 2r, weight at distance, you have to calculate the weight at a distance 2r. Weight is nothing but force, which is g into capital M small m by 2r the whole square. G capital small m by r square, which is 2r the whole square here. So hence you can write it in terms of new weight, you can write it in terms of given potential energy. Given potential energy at surface is G capital M small m by r, which is represented as u, so u by 4r. The gravitational potential energy of the body of mass m at a distance r from the center of the earth is u, similar sum, the weight of the body on the surface of the earth. So you know u is g m by r, weight is g m by r square, so it's u by r. So that's about this. Please thorough this. I'll try and make the other video whatever I can. I'm sitting, cancel the class. I'll try my best to finish everything for you.